Hello guys, so we only have a few minutes, so we will start. We had the chance to build the GreHack teaser with the Sodu Robber, my team, my CTF team. I am FDL Sifu, and I was the author of Remote AES. I will explain you how to solve it because we receive very few solves. So the challenge was basically that prompt. We were providing the encrypted file, so encrypted with a key. We were saying that in that challenge it was AES, remote AES with a student and some keywords like that. And the category was side channel, difficulty was hard. We received some comments. It was well received, I guess. But it was not guessy at all, but I will try to explain you a bit of the workflow. So basically, the category, as I said, it was side channel. We talked about security evaluator, and we also mentioned that it is a test implementation. So basically, it's a remote side channel attack on AES. So I would like to do a demo, but the problem is that it's not my computer. So I did some screenshots. So we have that remote server. We catch a trace, which I mean, you send 16 bytes and you receive a trace. And if you plot that trace, you see that there is some patterns that are duplicated. Those are the patterns that I made on purpose to synchronize. If you try to do a side channel attack on the raw traces like that without synchronization, you will find nothing. And you have to do some synchronization. So how to do the synchronization? Basically, I've implemented the sum of differences. So I have a sliding window where I compare the traces with my trace of reference, ref trace, the second argument, and my array that contains all the traces. And I, with a step of 1, I go through my sliding window, do the sum of differences, and I take the minimal, the smallest sum of differences that I found across my window. That synchronized my first pick because I took the first window. So we see in the red pattern, which is the first synchronization. We do the side channel attack using the correlation power analysis. It failed because we needed a second synchronization on the second pattern. Once we did that, we could perform the correlation with a simple algorithm like that or using a tool, but I do it in Python just to illustrate how easy it is once we understand the theory behind. So basically I have guesses, traces, and I compute the correlation of the two sets, and I try to find the one that maximizes the correlation. So I'm using here the numpy.corecof, which is basically that correlation function, and I do that on the output of the S-box that is happening at the first round of the AES. This gives me the key, which can be used to decrypt using AES ECB, so classic decryption, and to obtain the flag.